I would like to invite Shri Mahakur ji to present his talk on multi-scale manifestation of ISMR as evidence from TRMM PR observations. Sir, over to you.
Sandeep ji. Good morning and namaskar to everyone, respected director and seniors and my colleagues. I will be presenting on the multi-scale aspect of the Indian summer monsoon rainfall using solely the TRMM precipitation radar observations. For this, why you know that 75% of the energy that drives the atmosphere general circulation comes from the precipitation processes that is manifesting as latent heat and mostly from the tropics. And these precipitation processes are the variability involves several scales and that impacts the global circulation. And that not only that, it influences the weather around the globe, the tropical precipitation through this latent heating. These weathers influenced over the globe through modes of teleconnection. And with the advent of this precipitation radar, this estimation of precipitation has improved so much, especially over the coastal region and the mountainous terrain. Earlier, this before the TRMM, the precipitation over the tropics was uncertain, almost like a factor of 2. And with this data, this estimation has improved drastically. And as we recent papers, 2024, it shows that most of the precipitations happen within the coastal region. The coastal region that you find something like 300 kilometers from the coast, and beyond the coast, the range decreases, and particularly the wind-facing side, it enhances. So for this, as I mentioned, I will be using the TRMM precipitation radar products, and you know that TRMM satellites no more, but it had this precipitation radar, this one, and this radar is a solid-state radar with a phase array. So this power requirement, it was just like a household power, like 220 volt, 250 volt kind of thing. It does not use power. And this satellite, along with the PR, there are several precipitation related instruments, this VIRS, EMI, and LIS, and another CERAS for the radiation, but it worked only for 8 months. And this radar, it scans 0.15 degree down, so it translates to around 0.5 kilometers. The footprint size is 0.5, and the radar scans cross tracks along as the satellite moves. It tracks cross track, and the inclination of the satellite is 35 degree and a precision of 46 degree. So 35 degree orbital inclination restrict the satellite within this 35 south and north. So the data is only available for the tropics. That's why the mission name was that. And because of the 35 degree view, or that means the 17 degree both sides of this nadir, and with a 0.34 scan, it is make the 45 scan spot, 49 scan spot along this track, or you can say 49 rays, and this one orbit takes around 90 minutes, also per day, like kind of 16 orbits. And it has a repeativity cycle of 46 days. That means within a season, if I want to study diurnal cycle with this repeativity cycle, I can study using one season of data. But what is happening, the initial mission was for 3 years only. And as you can see, with the 3 years of data, the diurnal cycle cannot be studied because of the sampling issue. The number of observation you can see is especially inhomogeneous as well as temporary also. So to use the data for diurnal, at least I have to sample for, this is for 1 hour. So I have to sample for 4-5 hours or take a long duration of data. And even this resolution also, specialist being as half degree, not so fine. That's why this data quality, as well as because of this problem, the satellite was boosted during 2001 from 350 kilometer to 403 kilometer. That's why they increased the life to around more than 16 years. And this entire data will be using in this work. And this shows a map of this entire TRMM PR data 2A25. I am using that's the orbital data, and this has been to 0.1 by 0.1 degree So this you can see this data that the average the ITCL positions is fine locations of the rain bands can be seen, and from this you can find out that the average rain along this tropics is 2.5 mm, 2.8 mm per day, or something like 1.3 centimeter annually, and this was that the rains over the large islands, this is more rain than the surrounding. That was not so much known earlier from these other satellite data. And one thing is come out from this plot that I have been into 10 degree. So in higher resolution, this in quantity may change. That the highest rain occurs not over this Cherrapunji, but over the Papua province of Indonesia. This position I mentioned, somewhere in the SPCZ, and around 1,088 centimeter. The second peak is here, offshore of the west coast of Colombia at northern latitude, 5.5 degree, and because of this Andes. And Cherrapunji comes somewhere in the third position, around 840 centimeter. But if I to change the resolution, this value increases. Now, this shows a cloud pattern over the tropics using Calypso data. I plotted the vertical profile and this along this the latitudinal variation. So I have latitudinal average 20 south to 20 north, and you can see the clouds dominates over the monsoon region. This is the South Asian monsoon and the West Pacific, and this is Africa and the South America. And the clouds are very, very tall. So that means these monsoons, actually, these clouds are the dominant among the all these three monsoon region. And because of this, we try to analyze the space-time variation of the summer monsoon, looking into the multi-scale aspect of the related with the circulation, the local landscape contrast, and the topography. That's why I will be concentrating only on the summer monsoon rainfall. So this plot shows the summer monsoon rain, 98 to 2016 years, JJS. So when you see the flash trends, this is the topography map, and this Western Ghats, in the Tibetan region, and the Suleban range, and the Arakan Yoma, and the San Plateau extending up to the Tenasserim coast. So at the first glance, so the rains are actually anchored to the topography. So this Western Ghats, and along this Arakan and the Tenasserim coast, and the entire Himalaya, and this the Garo Khasi Hills, extending part of the Indo-Myanmar range. So, and that means this monsoon actually, even at a large scale, actually influenced by the local topography. Okay? And this I will zoom and show separately. And the importance of this band and this one also I will be discussing detail later. So you can see this from the Arakan coast, and this rain, the band decreases and goes up to the this northwest pass till the Aravalli range, and thereafter it decreases. And because of this Suleban range, there is another band, although it's very light as compared to the other. This figure now resembles that the rain that occurs over this region actually having a low level moisture. This is 850 millival from the era 5. Specific humidity, this region very high, and the wherever it is occurring, these bands, these are within the same range, and the water is also more than 45 millimeter. But this region, north of the Bay and Bengal through this Bangladesh to the eastern Himalaya, these are exceeding 65 meters per second. I said 65 mm. That means these are like a maritime region, or the convection. That's why here referred to a maritime type of convection. So now I will try to zoom this plot. So before that, this is just a frequency plot. So it shows that means the number of rainy pixels, upon the total number of radar digits during the 16 years, or what we call the frequency of rain. This frequency almost resembles the rain beds. That means wherever these rains, they are raining frequently. All these same pattern. Now, whenever I zoom it, we see something interesting. This the Western Ghats range basically the anchor to the topography. Now, if you see this white line, it's a 500 milliwatt topography line. So this is tightly anchoring to this, and this rain does not occur or only over the coast or the offshore, but the maxima is occurring over the first reach of the 500 milliwatt line. I will show some plots, the other data what they show later. So if I plot along a latitude 14 degree, it shows there's this topography from the same dam, and this is the rain, blue line. So the peak is occurring at the first reach, not at the highest summit. So the maxima actually it happens because of the westward moist wind and the impinging upon the first reach. And this is the coastline. This is not the coastline, but this other line. I will show a coast which is little far away, so you will see this same pattern. So coming to highlight that if you see other the popular data, for example, this data, if you see the rain bands are actually offshore, not even with the coast resolution. I make this PR codes. This pattern mostly in the offshore, and in the Bay of Bengal, it is north of the bay, not on the Arakan coast or the Tenasserim coast, and this Himalayan rain band is not well visualized. Similarly, this is in CMAP is mostly the IR and model output and other satellite gauge Mars, but this is the quality, but it's a highly popular data. Then if I use this another passive channel, the microwave only, and the land region is gauge data, so the cost you see the gap, and the passive microwave also showing the rain offshore, not on the coast, and here also it is showing but not tightly to the coast, and this band is from the gauge data. So it shows that earlier the passive microwave or the hydrometer optical data whatever you're using, they are actually not representing the rain bands. They are actually placing at different places far away from the coast or and the center of the North Bay of Bengal. Same thing, it's a coast is little far from the first summit. You can see the peak is not at the coast, but at the first approach here. So this IMOT also is very widely used. So if you see this IMOT profiles, sorry, IMOT maps, it shows that it depicts the west coast rain, but in a smooth manner. This whatever we are seeing this different local pockets of the heavier rain area. This is not properly coming in this IMOT product. But it is smooth. Similarly, in this Arakan coast also, it is somewhat appearing but little far from the coast, not exactly over the coast. And the Himalayan region also, it's like kind of smooth. Now, another thing I noticed in this IMOTs, although it's not directly related to this topic, that this blue lines are for the DGF ITCZ, you can say that is average within on this zonally average and this latitude, and this the amount, and the red is JJS. The solid line is from the radar only products, and this is the IMOTs. So during this JJS, we can see the ITCZ strength almost depicting same location, but this IMOT is kind of a smooth product. It widens the ITCZ range, but the significant difference you see this in the DJF, the boreal summer. This ITCZ is much stronger than the northern hemisphere. This is kind of a drastic difference in the IMOTs, and this is the PR product. So higher than PR, but this peak even this more than the northern hemisphere. So something it's showing that the IMOT is the southern hemisphere ITCZ is more kind of a amplified in this product. So, this shows the mean the circulation or the upper troposphere using the same data. This shaded is the divergence, and these arrows are the wind. So what I want to highlight is this rain that occurring over the Bay of Bengal the Arakan and the Tenasserim coast. Actually, these rains are basically happens because of the low-level convergence and this interacting with these mountains. These mountains are not so great, but it's 2 to 3 kilometers high, and they converge along this line. And with this presence of the LPS, this convergence again strengthens, and this produces deeper and deeper convective system, as in they are also prolonged if you see the life history, and that produces a large stratiform rain along this region as compared to the other region. Say, for example, the difference from the Western Ghat, that's the difference. And this region also produce because of this stratiform rain, and that's actually shown in the TRMM. And prior to TRMM, also during the Monex time, this 1979 House group has using this aircraft and the ship data. They have shown that this region produces almost more than 50% of stratiform rain, and that stratiform rain produces some kind of a top-heavy warming in this region, and that's really just tremendous amount of latent heat, and that produces actually strong divergence here. This can be seen from the ERA data and increasing the TJ. So this elevated tropospheric heat, upper tropospheric heating actually there is mostly of convective origin, not like that the Tibetan sensible heat. And that actually maintains the meridional temperature gradient that is used as a PT gradient by the sustenance of monsoon by the Goswami et al. In this group, because of actually that actually comes from seen from here, that's mostly from the latent heat origin or the convective origin. So this is the role of that Himalayan region. Now coming to the Bengal Ocean, coming to the Himalayan region. So this region, the rain when I only few, but I will highlight later. So we used to say extended range here. So that Himalayan range actually around 500 HPA. So I use the 500 HPA wind. If you can see, the Eastern Himalayan environment is drastically different from the Western Himalayan. This shows that Western Himalayan winds are basically easterly and they are dry. They're like 1 or 2 grams of humidity, but this region is moist. So the rain bands which is appearing over the Himalaya western parts of the east, they are actually coming from a different environment, and that actually I will highlight later also that this is the actually unique as compared to the Western Ghat and the Arakan and Yuvan of this actually because of the southerly flow here, and this is moist and the upper dry, and this here the moist, and this region actually as I mentioned also more than 65 mm of water vapor, and this actually interaction produces some kind of intense MCS over this region. And this other plot actually I have just zoomed the first figure that we in the Himalayan region some data show one band, but the June figure it's something it's so new that is there not has been reported many of the literature. The rain band basically not one, actually two. You see from the eastern Nepal to the west of Uttarakhand, it's actually 2 bands and like a closed ribbon or a garland. So this actually, if you see this topography, this is the 500-meter elevation and the 3-kilometer elevation. So one coming closely parallel to 300-meter and this 500-meter and 300-meter, and in between there is something like subdued region. That's actually not produced by many of the rainfall, and even the model also fails to bring this to band or this ribbon. I just to highlight this role of this orography or how this dependence of the orography rains important. I have just taken this help of this reference. So this is by G et al. 2006 published in Journal of Climate. They conducted a regional experiment using this entire microphysics and the with the 0.5 resolution, and this produces the simulation some kind of like this, that we see this West Coast rain, some kind of a diffuse Himalayan rain band, but this Arakan Yuma rain band is missing, and there are also other the Himalayan the Philippines or the Laos range that that the rain bands are also missing in this experiment. This is what is called the control experiment. Like what they did later, they prescribed the diverting heating along the Arakan-Yama coast and one over the Philippines and the Laos orography, and run the simulation again, and it could produce this Arakan-Yama band and this band and this band. And but what it gives something interesting, even if they do not prescribe the diverting heating along the west coast rain improved drastically. So this is the anomaly. So these are the regions where this diverting is in the place. So the west coast rain increased. This rain appeared, and these two bands also. But the Himalayan actually not coming significantly here. So this experiment demonstrates the effect of this large-scale localized rain or the localized rain band attached to the orography to the large-scale monsoon. This diverting heating here, sitting locally, not only they produce the local precipitation, but they intensify the hydrological cycle as a response, rocky wave response. And this far-reaching effect can be seen as this some sort of a realistic monsoon in this region. So these rain bands anchored to the orography, these are actually not kind of local. They have a remote or the large scale effect. If they are not properly simulated or they depended in the model, it will have larger implications, adverse implications. Now, from this climatology, to understand the climatology, what we did, we separated the same radar data into different precipitation system. Precipitation system, these are actually to understand this regime of precipitation. So this precipitation system, what is called as a small precipitation system or medium system, large system, that will probably help to understand the climatology of the rain. So what we did is contiguous pixels, the raining pixels, say less than 79 square kilometer, or the size or the diameter less than 10 kilometer, that is a cumulus or meso gamma scale. We say a small precipitation system, and the 10 to 100 kilometer as the medium, and the size which are more than 100 kilometer or something like 8,000 square kilometer nearly, that's a large precipitation system. So I will try to show that climatology, how it is represented, whether they are represented by any of these systems or how this system contribute to that climatology. So this is just a rain what they produce. These are all the maps of the small precipitation system, average rain. It's very little, coming maximum of 2.2 or 3, something like here. And the average is around, say, 0.5 kind of thing. That means 0.5 mm per hour, it is something like 15 centimeter of rain during the season. But what it comes out, they significantly appear over the 300-meter contour or the higher Himalayan ridge and the Arabian Sea and this offshore, and not mostly over this region or this region. They appear very less. And this the medium-sized system, and they you can say meso alpha beta kind of thing, and their intensity is up to 0.5 or 6, 0.8 here. So their presence is actually widespread, and this important thing is that they are also appearing in between the ridge. This is the low area, and the mediums are dominating here and on the west coast, and some are near the coast also. So I will just similarly zoom this one and the next plot to show you how they look. So this is the medium. So medium size, if you see this, it actually representing the mean rain pattern. They are also anchoring to this orographic. And that means this Western Ghats rain or the range, Himalayan range between 500 to 300, they are mostly of the dominated by the medium-sized precipitation system. Now, if we go to their larger size, this figure, this is the rain that produced by the large size. They are very high, the highest than the other size. So as the system size increases, the average rain producing efficiency actually increases, and it's going up to even 1 millimeter per hour. So they are actually representing, if you see the mean pattern kind of thing, in the western coast also, but not that significant bands coming. And if I just plot only the rain pixel, which is more than 10 millimeter per hour, the heavier rain pixel, their frequency appears something like this. So this is like the mean rain pattern. That means where there is a large rain bands, they are not only they frequently rains, but they rains heavily also. The heavy rain is kind of a normal to this region. It's not like extreme. Now, but how much they contribute to the seasonal rain? So if you see this small precipitation system, they are actually not so much contributing over the mainland. I have small this mean contribution I have flagged out. So if you see here, this is like more than 80 to 90% over these upper regions of the Himalaya and the Tibetan plateau western side, but not on the eastern part, and some on the Arabian Sea. But this figure I have not shown, but this large system actually there are plenty over the southern coast there. Now this medium system, same thing, is over the Western Ghat and in between these two bands of the elevation, 500 and 300 meters. And along this coast, there are less, but they appear somewhat, but not that intense. And this is the contribution from the large system, or this system size having size of more than 100 kilometers. So if I can see along the west coast, they are actually have, but it's minimal. The Himalayan on the gazing plains, below the 500 elevation, and here somewhere on north of Arabian, but their mean range is very less. But significant is the entire Bay of Bengal and extending up to the central India. So that means if you see the contribution, they are more than 80%. So the monsoon rain or the Bay of Bengal dominated by the large system. So whenever, for example, a model produces a dry bias kind of here, the central India or Bay. So can you say that this, even if the model resolutions are increasing, they are actually unable to represent even if the large system, the more than 1,000 kilometer size. So maybe this model has to follow this life history or the grid history somewhere in the latter backstage. Now, to highlight the importance of this Himalayan region, just I'm showing this schematic of the house to differentiate how the rain differs in the eastern and the western Himalaya. So this one actually same Calypso plot for the JJS region is showing a latitudinal relation. If you see the clouds are basically taller on the northern side of Himalaya. This is the average of 70 to 90 degrees. So somewhere 20-25 north, and they are slightly less height. But when the south of the equator, again, they are increasing. So the monsoons actually, if you say the hardly sail actually elevating this clouds probably at the higher height in the northern side. But along the Himalaya, what happened? This is a plot from this OR that they separated this system as deep. If they are the 40 dBGs, height is extending 4 kilometers. But same criteria, but if they are horizontally somewhere like 1,000 kilometers, and without even a convective rain, if this echo's size is more than 50 square kilometers, they call a broad stratiform area. So these three categories they try to analyze, but the sample size is very less, 100 to 200 samples over the Himalaya, and they produce this schematic. So what they shown that the Western Himalaya, these foothills, the clouds are actually very deep, but they are not so wide. But in the central, they are very deep as well as wide. But the eastern, whatever mentioning as the maritime region, they are mostly of the broad stratiform areas. That means the heating from this it will be at the top heavy as compared to the central and the western Himalaya. So just to look at that in some different ways from the rainfall, what I have shown is how much is the relative frequency of rain if it is raining heavily, say 10 mm per hour, and compared to the number of raining pixels. That means if it rains, that how much is the extent. So if you see along the Himalaya, the western portion extending upon this San plateau, they are actually more than 40% of time, if they rains heavily as compared to the eastern part. That means the convection, however, so is very tall or the intense. They are actually showing in this rain also. So this is because of what? This region is basically dry easterly at the upper level. But when the monsoon moist South Australia westerly flow over this semi-arid region, they get warm up. But this dry air, this what is sort of lead to them. So they prohibit this release of the convection, the energy. But when they impinge upon this Himalaya, the orographic force for the convection. And when it is a break kind of situation, the synoptic system also help, and because there's drop there, and they actually occasionally produce this intense MCS or some kind of the Ali or the Leh or kind of episodes. So this region basically, because of this rise easterly, and then this kind of the rain production is basically a kind of a multi-scale interaction. The local circulation topography, and then the synoptic flow of the flow, moist flow, when the orography diagonally this energy pushes this air close to the foothills or the provides kind of a heat, and this air rises and produce extreme rain. And some of these intense actually some produces a very disastrous kind of rain sometimes. And this region also actually a lightning hotspot. If you see the lightning melt, they are the classes of kind of one class at least in 5 days. So this because of the monsoon and the local topography interaction, where the eastern portion is basically the moist monsoon and the topography, and they are producing this large stratiform rain and this different heating pattern. Now, going through this, how the rains change diagonally, this is actually well known everybody that this continental region actually gives a continent afternoon peaks, and it's everywhere observed. And I will just show here only some fine scale pattern with this data. And some 25 years before, the Krishnamurti and Krishnaji has shown that this summer monsoon time actually it shows a continental diurnal cycle. That means the afternoon the divergence pattern is very largely enhances because of the ascending this convection, and this the divergence branch is so high that the easterly jet enhances by 5 meters per second in the afternoon as compared to the morning. And this diurnal pattern is known, and it is shown in the cloud and water, the wind also. And they found that this wind, but somewhat 2 to 3 hours delay than the cloud. But I want to show this fine pattern with this data. So the one thing that is coming here, this push force, these amplitudes, they do not show any significant diurnal peaks, and the amplitude also very less if I normalize the mean. And similarly in these rain bands also. So they're not terminally prominent. That means they rain continuously throughout the day. But the difference is that in between these two regions, the 500, 300, this is mostly afternoon, and the peak also afternoon. But below 500, till this gazettic plane extending upward northeast, they are mostly the morning time. And this, what I've shown that this morning time, the eastern part, mostly these large precipitation systems initiates, and they propagate towards this south and produce heavy rain in the morning. And there is a second peak that comes afternoon. There's a by the medium-sized system. And similarly in those this region, there also morning peak by the large system, but this system they propagate significantly towards the Gangetic plain, and they produce again a afternoon peak by this large system, then intense rain also. So most of the morning rain that's why happens over this region. And something to highlight is this belt. I just plotted this how much this rain, monsoon rain contribution gives to the annual rain. Just if you see this belt, there's actually this monsoon rain is like around 50%, unlike the other region. So this region actually is rain may be coming from the other season also, not only the monsoon season. And the other significant finding in this analysis is the Central Bay of Bengal. Most of this coastal region they have peaks in the morning time. Here also we see that medium and small they form in the morning, but the central region they are actually noon to noon to afternoon. That means this system we have to examine detail that probably they form somewhere in the coast, they propagate to the Bay of Bengal at center of the bay, and they in the noon time they enhances or the diagonally they intensify and produce bigger convective area, not only the stratiform, and producing the intense rain as well as the broader rain area. So So this actually they are propagating in nature, and the central bay is mostly by this propagating convective system, the large and the medium, and they actually increases in size and they sustain for a long time. Now, just to highlight the diurnal change along the west coast, this is the dotted line in the coastline, and that's the longitude here, and the local time. So if you see this, the ridge area, not the coast, is raining continuously throughout the day. There is no significant diurnal peak. Some little bit morning it is showing here, but that means the rain which occurs on the Western Ghats actually forced by the wet, the moist westerly wind as a kind of the mechanically forcing this wind and this convection is forced by mechanically forced by this moist wind, and then with the help of the orography. And just to see this interstitially how they change. So this is the active break I pick up using the IMSR because there is no temporary continuity in the PR data. This is the active pattern and the break pattern. So this coastline actually, even the rain or even in the break time also, but the western side of the Bay of Bengal or the central India is kind of place. So what actually trying to see that this the west coast of India actually the diurnal peaks, even if the amplitude is less, they are actually forming in the afternoon in the break situation. That means the rain which is formed in the break situation is actually forced by the thermal force and not like a mechanical force. But since the magnitude is small, that shows that this thermal force is weak, a weak force as compared to the mechanical force. So this is the summary. This I am to highlight. So what actually I have shown that the rain, whatever we are getting, is basically a orographic enhanced rain, and this orographic rain pattern is basically not represented many of the rain popular rainfall products, and this actually formed because of the multi-scale organization of the local topographic, large-scale circulation, and the diurnal force to some extent, and the Bay of Bengal is typical to the other region. And then, as I mentioned, the Western Ghats rain is mostly the mechanical fleet, and the break time rain is mostly governed by the thermal circulation, and this is weak as compared to the mechanical forcing. Thank you.
Thank you so much, sir. It's indeed a pleasure to listen to all of this, and it's fundamentally quite eye-opening. And with this note, I would like to open the floor for discussion. And we have some YouTube comments as well that I'll be taking later. So first, I'll open the floor for discussion. So,
Mahakur, this is very good study. But one thing that I am missing in this whole thing is that the limitations of TRMM PR. Some limitations because of the PR data. So we have underestimation of light rain can never be
0.5 mm late is can.
But also when it comes to very extreme events, that also it misses.
No, extreme event, whenever it passes, because it's snaps of kind of observation, it picks up. But
But the amplitude will not be correct.
amplitude will be correct as compared to other passive edges that I have shown.
Okay.
But I think is that it does not have the chance to observe probably. So we should have like multiple radar and like GPM. We have two frequencies. Actually, beginning it was proposed in the TRMM time that we should have that GPM kind of instrument, but because of funding and the limitation, they launched only one channel. Actually, this.
So as a result, what happens is that your statements like Cherrapunji is not highest rainfall and
So that actually probably
that will have some problems.
that probably because this point versus grid. This is like 100 square kilometer by 100.
Yeah.
If I increase the resolution to half, sorry, 0.05 kind of that enhances. But that surrounding, I think it does not rain so much. It's typical this thing. And one thing I forgot that Kasturji also there that I was talking to him. This plot actually shows this one pocket here. This is a border, international border between India and Bhutan, called the south of the Pilsu Wildlife Sanctuary. This actually in the summer monsoon is raining higher than the Cherrapunji. Probably you have not observed. So I was asking whether you can have anything to put a rain gauge there or see.
So second thing, that very interesting part of your study is that a classification of small, medium, and large scale rainfall patterns. So I'm very much doubtful again when it comes to small scale, the contribution to the all India summer monsoon rainfall across the summer monsoon season is almost zero. No,
It's very less.
it doesn't.
That means even if there is some small cloud or this thing, we worried about the high levels on this thing. They do not contribute so much to the rain. Probably they may be
No,
transported.
that statement maybe we should take it with a pinch of salt.
But that comes coming from the observation.
So maybe I think you should complement this study with your other rain gauge data to see how these two different results match with each other.
In the data, again, now we cannot separate like this. How is the size of the rain? But some
Now we have a very large data distribution, no? Rain gauge distribution. So wherever is possible, the Mumbai Meteorology is very densely populated. Again, Delhi, we are having it. So like that, we have to see what is that. This looks to be very counterproductive because light rain doesn't contribute at all to the.
this is not light rain, actually, this is light
Light rain,
rain
yes.
from the large
Small
system,
scale.
small rain cells,
Hmm.
cumulus scale and the mesogamma scale. They are not actually contributing. They are contributing here, foothills, the Southern Ocean, they are this Arabian offshores.
So again, this also maybe because of again the sampling problem. See, the repeated cycle is 46 days. The path is about 216 meters to 240 meters, 240 kilometers. So that also can give you some of these other problems.
No, that actually is not a problem, but
But repetitive is not there, no?
actually this the other way. This large system may be undersampled because of this limit 250 kilometers swath.
Mm.
They may be undersampled, but the small samples, the small precipitation medium, they actually covered by the swath. This
But-
large system actually this satellite may
But
be
it
cutting.
comes back again after 46 days only.
46. This is the orbit repeats. Some point is maybe like after 3-4 days, but it's giving statistic. I cannot like analyze a time series kind of thing. But using this orbital data, we can produce a nice statistic.
These are some, no. Those are very interesting, but these are some of the conflicting results actually.
Actually, this radar.
We always believe that small scale interacts with the large scale, and then. Yes. So that somehow is something completely missing in this.
Actually, I will be analyzing with the gestation data also, like look into this all different sizes. And actually, one here this using this house there, this radar reflectivity, they have also shown similar kind of result. This small versus large, they produce more rain, and there's widely this rain is not because of only the intensity, because of the wide coverage. So they contribute more to the seasonal thing, because this convection and static convection is like 1:4.
Is that how much is the large scale is through again LPS? Also is very important to understand. This large size expression, how much is due to because of LPS, monsoon level pressure systems?
That's actually because of the samples problem. They have not using geostationary, that can be actually pulled out because the continuous observation. So here taking LPS and putting the data together, it will be less less sample, like this kind of mean.
So this is a good presentation. Sir, while forming this study, have you considered that satellite products have a backdrop of maybe a spatial spread in their rainfall while their estimation? Because in your classification of precipitation systems based upon area, I feel that there may be overlap between small scale and other scale system from satellite products because it is giving a more spatial spread. That what actually rainfall extremes happening in a very localized manner. Have you considered that limitation, sir?
No, actually, there is no overlap. We have like 10, 100 we have taken, But this is actually just to show that how much they contribute. But here, intense rain, if you, as I showed, no, they are actually coming from the where they are the large systems are there. But if you see the TRMM data quality, there are a lot of validations work, and this happens to be the very good data as compared to other. IMSR data takes all lots of satellite, but it's a temporal continuity. But problem is this intense rain area, some of are also highlighted. We should not use in the orography region intense rain, this IMSR product, because they do not represent the magnitude, intense rain magnitude properly. Where is this snapshot observation? If actually available, they are very useful.
Until unless we are verifying with any rain gauge product, we cannot know whether it is a small scale precipitation system or large scale precipitation
Yeah,
system.
actually from the radar, actually we can complement this. The radar covers lot. But if you remember this earlier, this TRMM this radar used to validate TRMM. Later they found that actually TRMM satellite is validating the radar. They synchronize all the international radar because the different radars, they were not matching. So instead of validating TRM, actually TRM validated the radar. So this data quality actually is not that much doubtful, but there are always some noise and something that we have taken care. The rain definite and the sometimes a spurious value that we have removed in this filter. I have not mentioned, so that we have taken care of. A very high spurious value somewhere. So whenever you see during the instantaneous value, very high value and it's not matching surrounding and so much different, we have removed that pixels.
Good presentations and lot of things are there. As directors are told, I am also in the same opinion because your definition of considering this system is some kind of issues. Because when you consider those systems, we are not considering the time continuous data as you are mentioning. So what is happening, because with this weather radars, not only our group, we have done several and ISC is also done. Storm scale convection is very important, which is completely missing in your analysis. And storm scale convection, you cannot do analysis with the trim because that is a limitations.
Storm scale means the small size.
Small size. So small size is contributing major fraction to this MCS.
The MCS.
Yes. So because you are getting
That
this
may be-
large scale organization,
Maybe I think case it is a long observation in the long term. They get
long term, 10 years of data analysis over the Kolkata, Western Ghats and Central India, we got those things. Important part is the life cycle. Life cycle is less than an hour because stream cannot resolve those things. So that's why all those confusions are coming. That's why when you consider the large size, there is a convective organization. So that's why you are getting all those analysis and other part of the thing. So that will clear a lot of the ambiguity why your small scale systems are not able to resolve none of the precipitation, because that is the reason. Another question is like that trim is a very well known. People compare the reflectivity, not the rainfall product, because rainfall is some derived product. So that is some different issue. But trim, no doubt about it, it is well known. I just want to have one curious, like you showed, like Cherrapunji is the third one.
yes.
Whether you have seen the vertical growth of the storm over
That I am not plotted over this region because this region anyhow this CZS then the eastern parts of Pacific, they are very deep system.
Yeah.
Cherrapunji also shows sometimes very deep, but all this I have not clubbed together.
No, because that will be very much interesting to see what the depth of the storm. Those three locations, whether
The project the rain producing efficiency because the Cherrapunji so the very large this
rainfall is the final product. You will not understand those processes. Rainfall is the final product. Bad gaya, kam gaya kind of things will happen. But the understanding the processes, if you can consider like CFD analysis, control frequency altitude diagram, then you can get more picture. And one more things like you say active and break cycle, which region you have considered to construct that?
the active and break I have picked up from the
Because
other region I have picked up from the IMSR data.
yeah, because Central India will not be the well representative of other place active and break because you are showing.
We are sending
several
this active break
places.
up for the Indian region, monsoon region.
But if you consider this,
And actually, see this, it's not linked to this Arakan and Mahakur. They range in the Indian mainland break also.
So if you consider this definition, I will tell you, southern India, you will get more rainfall during the break condition, and northern in this
Summer here.
yeah, because this is a diurnal cycle and other kind of the thing. So please consider those risks
No, it's coming. This break time not in.
coming, but if you consider like
It's
1 to 1. So this definition usually central India.
And the other thing is simple, very less, because the number of active break and the TRMM passes within there. You will not get like
Like
much other.
our Western Ghat Mahabaleshwar region, if you consider 1.5 standard deviation, you will never get a break there.
Mahakurji, we have recently done this paper for the Central India and the Kerala coastal. So it is active and break phase. It is totally different. It is happening over Central India,
Compared to south, what's the Central India?
Kochi region with respect to that rainfall data. It's totally different.
And one more thing, like diurnal cycle, because you know, again, this limitation of the trims come. I don't know, you have considered 1 hour.
Yes, we have sampled to 1 hour local time.
So, but if you consider this weather radar, Western Ghat, and other thing, you can see the clear diurnal cycle, which I don't know why it is missing in here.
Most of the author also they say that to
Yeah,
earlier.
just with the trim you will get. I'm not.
Western Ghat analysis,
but
as compared to the mean rain amplitude, they are not so much significant.
if you consider this high resolution measurement from radar, and you can clearly see those. Anyway, we will discuss more thing later. Thank you.
But maybe this, all the radar combined rainfall products of 4-5 years available, that type of work can be carried out.
Yeah, you can integrate all those.
Mahakurji, 1 or 2 points which I would like to support your analysis first. The point observations doesn't implies with the Cherrapunji में जितना rainfall हो रहा है, बाजू में उतना rainfall हो रहा है. Similarly happens for our Mahabaleshwar region. The Mahabaleshwar point observation is nearly 6,000. You come to Panchgam, it is 2,000. So this TRMM will not actually take care of the point observation. Secondly, Mahabaleshwar, आपका जो TRMM में दिखा रहा है, there is a diurnal variation during the monsoon time. We have seen or in the papers, and so we have done the analysis. Monsoon time do not have a diurnal variation, but the pre-monsoon time do have a diurnal variation. The similar thing is captured with your TRMM analysis. Actually, that Western Ghat region, it is not have a strong diurnal variation during the monsoon region. And this active and break phase, what Shubhrata was telling, it's a fact. Central India active and break phase totally different with the other coastal regions and all those things. That you should take care when you're taking care.
Actually, I wanted to say that during the break, this westerly weakens. So that weekend westerly actually giving this thermal kind of forcing, not this active time. Active time sensibilities getting drifted and
Yes, because we have done that. It's totally different. Total large scale features is also differentiating over coastal Kochi and Kerala. Okay, thank you.
I have one.
Thank you, Mahakurji, for a nice talk. I have a very simple question and a practical question. See, when you, what the director said that very low intensity rainfall like drizzle and very high intensity rainfall, they are very, radar peer is very sensitive to this band. So you have to apply a threshold when you do the practical calculations. For example, if we do the stratiform rainfall area and time aggregated values, so it will be highly sensitive to this threshold value. So my question is, what is the objective way to accept these threshold values?
That actually here we separated the size and not to get the magnitude, but it's already established before lunch also that 0.7 was its threshold for TRMM. But after this data come there, so it's actually very better than 0.7, so 0.5 kind of thing. So whenever this small system pushing the rain continuously, maybe that the drizzle kind, that may be giving us some underestimation because this 0.5 threshold and less. But this light rain also happens in the stratiform area also, our system. They are also, you can say that they are also, it might have given some bias.
Thank you, sir. So we have just one question from YouTube from Dr. Mukhopadhyay. So he asks, while you compare to rainfall among various satellite-derived rainfall, say IMSR or any other, which one captures the extreme 99th percentile better compared to in situ?
Here actually I wanted to I compared because they do not represent the geographical representation of the rainfall. So this 95% etc. it will come from the magnitude. I am not considering the extreme case, only the representation of the geographical location of the rain bands is not coming in other rain band, where the particularly passive observation, infrared or microwave. That actually gives the active. Unfortunately, till now we don't have any known this program. Suppose the GPM core retires, so after that there is no satellite. Even that time also they were telling that GPM time a lot of satellite will come, but don't have. And even the GPM, the IMSR contribution may quality may degrade because the USA now shutting down so many passive microwave satellites also. This actually concern, not actually we don't expect again so good quality data.
So he has two more questions, but that you can answer via email since he left the chat. So he has a class go. So, okay, on that note, just let us applaud Mahakur ji again for this wonderful talk.
This work actually most of these things published in this chapter as a book. Thank you, sir. Yeah. Like, actually.